Hello, and welcome to this short video on how to use the BC Fisher Habitat Working Group's Fisher Habitat spatial data. The purpose of this video is to illustrate how forest planners would use the spatial data in ArcGIS to identify retention targets for fisher habitats within proposed harvest cut blocks. We will walk through an example application of the spatial data and show how to use the output to identify retention targets for denning and resting habitats within a proposed cut block. The spatial data is based on 25 years of British Columbia fisher research involving 102 radio-tagged fishers in various study sites throughout BC. The spatial data is one component of the best available information to conserve fisher habitat during forest management operations in British Columbia. The spatial data is designed to help forest licensees incorporate fisher habitat into their operations by providing two key pieces of information. First, the spatial data helps forest planners identify habitats that fishers need for denning and resting at stand and landscape scales. Second, it identifies specific targets for each habitat and makes recommendations for retaining key structures within harvested cut blocks and the amount of habitat within the landscape. Spatial data is available as an ArcGIS file database for 4 fisher habitat zones within the province. Because the habitat relationships of fisher vary among these 4 zones, the habitat conditions and retention targets are different as well. Because of this, the spatial data is offered in 4 different feature classes, one for each habitat zone. Spatial data is available for all areas where fishers are expected to occur. Included in the geodatabase, we have developed a special fisher habitat tool to help you identify retention targets for your blocks. A few things to note. You will need to be running ArcGIS 10.1 or higher and have access to the Spatial Analyst extension. Second, your potential blocks will need to be shapefiles, not feature classes, and have at least one field in the attribute table that is called block to identify the name of the block. The tool will not run without this field occurring in the shapefile. It is very important to stress that the sole intent of the spatial data is to identify retention targets for fisher habitat and forestry operations. The data is not a predictive model and does not predict habitat suitability, capability, or importance, and therefore is not appropriate for analyzing the effects of developments on fishers or their habitats. Its sole purpose is to help identify targets and inform management decisions in this regard. This spatial data is designed to be used in concert with other information tools, such as the Fisher Habitat Management Decision Tables, various field guidance tools, and other products. Please visit www.bcfisherhabitat.ca for all available information and tools. For the rest of the video, we'll show you how to access the data and then go through an example of how to use it. The spatial data is available at www.bcfisherhabitat.ca, where you click on Habitat Tools and then select your habitat zone. A list of potential users of the habitat tools will appear. Select one of the roles in the leftmost column, such as Licensee Planner, and the Planning Tools downloadable tools will appear. Select Spatial Data and an end-user agreement will pop up to review and accept. Note that spatial data for all 3 habitat zones is included in this one geodatabase. Next, we'll go through a brief example of how to use the data. Okay, let's get to it. Let's say a planning forester has identified this white polygon, called CP102, as a potential unit for harvest. In the geodatabase that you downloaded from the website, you will find a toolbox that has a script that will run the analysis for you and export the retention targets for each portion of the cut block to an Excel file for use later. Simply navigate to the geodatabase and ARC catalog, expand the Fisher Habitat Tools toolbox in the geodatabase, and double-click on the Fisher Habitat Retention tool. This will run the Retention Target tool, which will prompt you for 4 pieces of information. First, you must specify which fisher spatial data that you wish to use. This will be specific to the habitat zone in which your cut block lies. In this example, it is Subboreal Moist Fisher Habitat Spatial Data 180427 feature class found in the geodatabase. If you are unsure which spatial data layer to use, you can open the Fisher Habitat Zone feature class in the geodatabase to find out which zone your blocks are in. Second, specify the name and location of the shapefile of the cut block of interest. In this example, it is cp102.shp as shown here. Note that the cut block shapefile needs to have a field named block for this tool to run. Third, you will need to specify a feature class to save the output polygons. Note that this must be saved as a feature class in an already existing database. In this example, I will simply save it to the default geodatabase for this session as cp102_retention_targets. Finally, you will need to specify where the Excel file is that you want the output information from the analysis to be sent to. Note that you need to include the file extension .xls. Press OK and we are off to the races. The tool will now conduct the geospatial analysis of these data and output the retention targets for each cut block that you specified. This will take as little as 15 seconds depending on the complexity and number of cut blocks that you specify, but may take several minutes. After the analysis has completed, the new feature class will plot that shows the overlay of the cut blocks on the Fisher Habitat spatial data. Each of these polygons will have different retention targets for denning and resting habitats. The easiest way to view the resulting output is to label the resulting feature class with a unique identifier for each sub-cut block polygon. Here, we open the attribute table for the new feature class and we can see that there are 3 polygons in this new layer and each has its own retention targets for denning, broom resting, cavity resting, and coarse woody debris resting habitats. If you scroll to the last couple of fields, you will find a field called Fisher Unit, which is comprised of the cut block ID that you referenced in the input shapefile plus a number. For ease of identification, we now label the retention target feature with the Fisher Unit, as these are the reference outputs in the Excel output file. To do this, we open the properties of the retention target feature class and navigate to the Label tool. Now, select Fisher Unit from the Label field drop-down menu. It will be very near the bottom of the list. Click OK, then go back to the feature class and activate the Label Features menu item. The Fisher Unit label will now show up. If it is of interest, you can then use the HTML pop-up tool to get more information about the resulting polygons. Activate the tools and then click on the polygon of interest and the retention targets will appear. Note that you will likely need to resize the pop-up window to fit the contents of the data. You will see that in this polygon, there are 4 retention targets that are identified. First, denning retention targets are identified, then broom resting retention targets, followed by the cavity retention targets, and the last section includes the coarse woody debris retention and creation targets. If we click on another polygon of the proposed cut block, and move and resize the window, you will notice that there are several warnings for this portion of the proposed cut block. This is because there are several aspects of Fisher habitat that are found within this portion that are rare on the landscape and these types of stands may be limited. You will see that there is a warning to reconsider harvest of this polygon as a type 1 broom resting stand, and the supply of these stands in a landscape is below the target for fishers. We suggest that the harvest of this area be avoided, as harvest would be expected to have a pronounced impact of the fisher that occur in this area. Likewise, this is a type 1 stand for coarse woody debris resting, and the supply of these coarse woody debris stands for fishers in the surrounding landscape is low, which provides more evidence that this part of the stand would be best to avoid harvesting if maintaining fishers in the landscape is desirable. Thank you for taking a few minutes to watch this short video on how to apply the Fisher Habitat spatial data in forestry operations. For more information about Fisher Habitat spatial data, other habitat management tools, or the BC Fisher Habitat Working Group, please visit www.bcfisherhabitat.ca. And finally, we'd like to acknowledge the funding provided by these organizations. Without their gracious support, this work could not have been possible. Cheers.